Hey all, welcome back to the channel. My name is Milos, and today we're bringing you an introduction to cloud computing. Specifically, we're focusing on Rumble Cloud, which is the newest player in the cloud computing game. They have awesome services that everyone can use to build out your applications. We split this course up into 5 different modules. Very easy to follow. It's just a slideshow presentation. There's over 2 hours of video content, and at the end, you guys can use the practice exams that we've set up for you. Thanks for watching. Please click like, subscribe, and we'll see you in the next section.
Okay, in lesson 1, we'll talk about introduction to cloud computing. What is cloud computing? Cloud computing, simply put, is just a method of building and running applications designed specifically for cloud environments. So instead of relying on physical servers, these applications fully utilize cloud infrastructure to improve your efficiency and flexibility. The goal here is really to help businesses develop faster, scale faster, and manage software quickly and efficiently. By breaking applications into smaller independent components, often called microservices, each part can be updated and scaled without affecting the entire system. If we look over to the diagram on the right here, we have different services that are fully split up so that each one can be updated independently of the other. This modular approach allows for faster development and deployment, making it a lot easier for the business to adapt to changing business needs and technologies as the years go on. Nowadays, there really is no need for physical servers. Simply, you pick the right type and size of computing resources you need, pay as you go or pay monthly. As it is for Rumble Cloud, you pay a monthly fee. And as it is for Amazon services, you can either be charged on demand or reserved instances. Depends on which option you choose. And from there, you can also just access as many resources as you need in almost an instant, right? And this turns out to be a lot cheaper than buying your own physical servers. And it really does lower your infrastructure cost as a business. These cloud computing service providers use a lot of technologies like microservices and containers and orchestration, different key components that we're going to touch on in the next section. However, these technologies make running and building applications flexible, scalable, and a lot easier to maintain. The 5 key components are microservices, containers, orchestration, CI/CD pipelines, and DevOps practices. The first one we have is microservices. So applications are broken down into smaller, independent services, each handling a specific function. So this allows teams to develop, deploy, and scale each service independently from one another. For example, here we have an e-commerce website, which has separate services for payment, product management, and user authentication, all right? So these are fully independent and decoupled from one another. That is an important word that you should know, and it is decoupled. All right. The next thing we'll touch on is containers. So containers package application code with its dependencies, and they ensure consistent performance across different environments. So containers package application code along with its dependencies, and they ensure consistent performance across different environments. And all a container really is a Docker image. And a Docker image is just a file with a set of instructions on the operating system, where our application code is coming from, and what kind of dependencies that we need to pull. Once we have that Docker image, we can make multiple different containers out of it. What that means is that we can have about 10 different applications that are the exact same. They're already packaged, they already have the dependencies, and we can just make as many as we want out of them. This means that developers can move applications from development to testing to production without any kind of compatibility issues. And this ensures portability and consistency across different environments. And the most popular containerization software is Docker. It's a widely used platform, and it's used for creating and managing them. So let's have a look here. So this is our infrastructure, okay? And then on top of that, we have a hypervisor. We have a physical server, and we have a hypervisor, which manages virtual machines. That's all it is, nothing complex to it. It just creates and gives us resources to virtual machines, all right? And on these virtual machines, we have app A, app B, app C. All of these can be the same container. They can all come from the same image, all right? Because they have the code, the dependencies, and all the other instructions. They can be run wherever. There are no compatibility issues, so it's super, super easy to run that application on any kind of virtual machine. Moving on, we have orchestration. So tools like Kubernetes automate the deployment, scaling, and management of your containers across clusters of machines. So you can have 50 VMs And Kubernetes is basically your command center, your control center to deploy these containers on those different virtual machines. So Kubernetes handles tasks like load balancing, scaling applications based on the demand, and rolling out updates without any sort of downtime. So these automations really simplify management of these complex applications. So in short, Kubernetes is your control center. It allows you to deploy, it allows you to scale and manage different containers across different machines. Next up, we have CI/CD pipelines, and that is an acronym for continuous integration and continuous delivery. This is for pipelines that automate the testing and deployment of code updates. So this allows developers to release new features quickly and reliably. So in our case, we have tools like Jenkins, GitLab CI/CD, Circle CI, which help automate this entire process, all right? So this entire process can use those tools and automate everything from release, from planning to coding to building to testing to releasing to deploying. Your entire infinity loop here can be managed from one single CI/CD software. So let's have a look right here. We have our planning. It's our planning phase. We have our code. Let's say we make a Git push. We build that on our CI/CD. We test it on our CI/CD, and then we release it to wherever we want. You can release it as a Docker image. You can release it on cloud service providers. And from there, we can also manage our infrastructure using Chef, Ansible, Kubernetes, and monitor our KPIs and logging through Nagios, Splunk, Datadog, whatever it may be, CloudWatch, and other services. Last but not least, we have DevOps practices. Simply put, it's just a combination between development and IT operations. And really the goal is to shorten the development lifecycle and provide continuous delivery with high software quality. So in cloud native computing, DevOps fosters collaboration between developers and operations teams so that we can automate infrastructure management and put an emphasis on monitoring and feedback that infrastructure. So for example, using infrastructure as code tools like Terraform allows teams to manage and provision infrastructure through code, improving consistency and just the speed of the deployment, right? And last but not least, let's just go over a few of the benefits of cloud computing. Give you a quick summary. You have agility, so you have rapid development and deployment, which enables your business to respond quickly to market changes and customer needs. You have frequent updates without any sort of downtime, okay? So you can release often, no downtime, your customers can still use your application. Then you have resilience. And resilience just means you isolate your components so that you reduce the impact if something fails. So if one component fails, the rest of the application continues to function, reducing downtime. And again, this goes back to something like microservices where everything is independent, it is decoupled. That's the word that you have to remember. It's all decoupled. So if one thing breaks, everything else continues to live on. Thirdly, we have portability. So your applications can run anywhere, either on-prem or in the cloud. They can run in any environment, public cloud, private cloud, or on-premises without any significant changes. And last but not least, you have cost efficiency, which is probably the most important thing for your business's bottom line. You have efficient resource use that lowers your infrastructure costs. You do not need to provision your own physical servers. You simply go to a cloud service provider. You pay as you go or pay some monthly fee or reserved instances, whichever service provider you go to. It will always be cheaper to do that nowadays than buy your own physical servers, costing you setup time, costing you software updates, and all that other crap that you don't want to do anymore. Just go to service provider. It's a lot cheaper and they'll get you set up. And finally, we have cloud computing with Rumble. So Rumble is a platform that integrates with Kubernetes to provide you flexible, scalable infrastructure for building and running cloud native applications. All right. So it offers you powerful tools to do this. Rumble offers a dedicated pool of resources. So what this means is that those resources are yours. No one else will be using your servers. And they're built on premium, latest generation hardware at very predictable and transparent monthly prices. So what this does is it eliminates that volatility and consumption-based pricing that you see a lot of other service providers use, such as Amazon, where you maybe 2 weeks into the month, you get a insane charge because your usage went up. You get charged like an extra $100. That won't happen here. You simply pick how much CPUs you want, how much memory you want, how much block storage you want, and that is your monthly bottom line. Very simple, very easy to use. You know exactly what you pay for. There's no hidden fees. And that is cloud computing with Rumble Cloud. We'll get into this in later courses. However, that's just a quick overview. I'm going to leave you with the summary and glossary right here. You can have a look before we get into Module 1, Lesson 2. Lesson 2 will touch on virtualization. You may have seen this already. This is simply just how VMs work. All right, so what is virtualization? Virtualization is a technology that allows multiple virtual machines to run on a single physical machine by using software to divide and share those hardware resources. So if we look in this image, very simply, these are our virtual machines. These are not physical machines. And this is our hypervisor, which tells us how much CPU, how much RAM, and how much storage we're going to take from our physical server and give to our virtual machines. This is fully customizable, and it depends on what kind of application that we are trying to run. So businesses use virtualization to optimize hardware utilization. This allows them to reduce costs and also manage multiple applications more effectively. Each virtual machine operates like a standalone physical computer, but shares the physical resources of the host machine, as I've shown you right there. There are three main types of virtualization. So we have server, network, and storage. Server virtualization, multiple virtual servers run on a single physical machine, increasing resource utilization and reducing the need for additional hardware. For example, one server can host a web server, database server, and file server simultaneously, all right? And each has its own virtual environment. Next up, we have network virtualization. So virtual networks are created on top of physical networks, allowing for secure and flexible management of your network traffic. So this enables different departments in a company to have isolated virtual networks running on the same physical infrastructure. And this can be very much compared to something like a virtual private cloud, which we can have multiple different subnets. So you can assign one subnet to another team and a subnet to a different team, but it is all under the same virtual private cloud. So having this run on the same physical infrastructure allows you to enhance security and simplifies your network management greatly. The last one we have is storage virtualization. So this combines multiple physical storage devices into a single virtual storage pool. So instead of managing individual storage devices, administrators manage a consolidated virtual storage resource. So simplifying storage management and improving that scalability. So you have one big resource pool, and then you simply can dedicate different parts of that, some bigger, some smaller, to different servers or people, whoever needs any kind of storage drive. Furthermore, let's talk about the benefits. Why do we need virtualization? Well, simply put, the first one is cost savings. So by running multiple VMs on a single machine, businesses can reduce the need for additional hardware. And at the end of the day, that lowers your CapEx, your capital and operational expenses. All right. This also just reduces energy costs, right? Secondly, we have improved resource utilization. So this will maximize the reuse of your hardware. Virtualization ensures that hardware resources like your CPU, memory, and storage are used efficiently so that you're not wasting that kind of capacity. You may have an application that barely takes up any CPU of the VM. So you can maybe split that up into different components and throw in some more applications so that you're utilizing it to the maximum. Thirdly, we have scalability. So virtual environments can be scaled up or down easily based on demand. So this allows businesses to quickly adjust your resources to meet any kind of changes. So you can scale your virtual environments based on the demand. If your application is not using too much of the virtual machine's resources, just scale it down. And maybe you can allocate the rest of that to a different application that can use it. Lastly, we have isolation and security. It kind of goes hand in hand with this, but each VM is isolated from the others. So if one fails or is compromised, the others remain completely unaffected. In the end, this enhances your security and your scalability. Finally, we got virtualization in Rumble Cloud. So Rumble Cloud utilizes virtualization technology to offer virtual machines and networks, all right? So these virtual machines allow businesses to quickly deploy isolated VMs and scale them based on their needs. So scale them up or down. And this also just ensures both security and flexibility. So some of the key features we have is easy provisioning. It's very simple to spin up a VM on the cloud with pre-configured templates. All right, so let's write that down. We have provisioning. We also have scalable resources. You can adjust your CPU, your memory, and your storage allocations on demand, right? It's very easy. We also have integrated networking. So we can create virtual networks and manage network configurations very easily. We also have monitoring. So we can use built-in tools on Rumble Cloud to monitor our performances and manage our resources efficiently. If something is utilizing a lot of CPU, That's bad, right? We don't want that. We want to have a look at that and maybe adjust for that, maybe add more, allocate more resources to that server so that it's not, getting the CPU to 90% or something. And finally, we have security features in Rumble Cloud. So we benefit from isolation, encryption, and access controls to protect data and applications in Rumble Cloud. So Rumble Cloud provides an intuitive platform for managing and scaling virtualized resources. So this enables your business to focus on core activities without having to worry about the underlying infrastructure and the complexity of it all, right? So you can focus on your business. I'll leave you with the summary and glossary here to have a look before we head into the next section, where we are going to talk about virtual machines a bit more. Okay, welcome back. In lesson 3, I will be going over virtual machines, not virtualization, but we're going to dive into virtual machines specifically. So a virtual machine is a software emulation of a physical computer. So it behaves like a real computer, but runs within virtualization software on a physical host machine. VMs enable multiple virtual computers to operate on the same hardware simultaneously. So you could have 5 VMs on one physical server, and this is being controlled by, as we've seen before, a hypervisor, which is like your VM command control center, right? So each VM runs its own operating system and applications. It's acting independently of other VMs on the same physical machine. This setup maximizes hardware utilization and efficiency by sharing resources among multiple virtual environments, all right? So let's have a look at how that actually looks like. So as we can see here, we have virtual machines on the left here, and just simply a physical machine here. But these would actually be layered on top of this, but for visualization purposes, I want to show you the different components and how they are spread out. So we would have 1 VM, 2 VMs, 3 VM, and each one gets dedicated CPU, gets dedicated memory, and storage, right? And within that, we can also take different snapshots. So let's go through these key features here so it makes a bit more sense. Isolation. So each VM is isolated from others. This ensures that issues in one VM do not affect an issue in the other VM, right? So this isolation enhances your security and the stability of your virtual machine. Then we have portability. So VMs can be moved easily between physical servers, making them ideal for load balancing, for maintenance, and for disaster recovery if something goes down. This portability allows for flexible deployment options, really. Then we have resource allocations. So virtual machines can be allocated specific amounts of CPU, memory, and storage based on their workloads, based on the setup you do to the VM in the beginning. You can assign these 3 things. So this enables efficient utilization of hardware resources and prevents overconsumption or underconsumption. So you can provision exactly how much you want if you know exactly how much the application uses. Then we have snapshotting. So simply, VMs can have their state saved at a specific point in time. So if something does break, there's an easy backup for you to restore that VM. So snapshots simply simplify that process of rolling back to a previous state because we have a snapshot of it, right? As you see on the bottom right here, this just shows that we can snapshot any VM and that is saved, and then we can re-provision it later. What are some more benefits? So they have several advantages, so I'm just going to outline just 4 here for you. But flexibility, again, it can just run multiple operating systems and applications on the same physical machine. So it can support a diverse amount of workloads, different kind of applications, and different testing environments. Then you have cost savings. So you reduce the need for multiple physical servers. You can have one physical server, and within that, split up the resources and have maybe 10 virtual machines and run applications on those. Thirdly, we have disaster recovery. So your snapshots and backups make it easy to recover from failures or data loss. This, again, just enhances your business's continuity and resilience to recover from failures. Finally, we have your scalability. So VMs can easily scale up or down based on workload demands. If an application has more usage, it will scale up, bringing in more CPU, more RAM if necessary. And this really, these VMs allow for dynamic resource management depending on your workload, all right? So that is what makes them so powerful. Finally, we have virtual machines in Rumble Cloud. So Rumble Cloud offers a robust compute service where you can create, manage, and scale your virtual machines effortlessly, okay? You have easy deployment, scalable resources, integrated networking, monitoring, and support for multiple operating systems. These are all things that you can pre-plan and use before you deploy a VM, all right? You also have deployment templates, custom configurations, allocate as much resources as you need, for which you will be charged on a monthly basis instead of on demand, like other service providers, which may charge you a lot of money if you have high usage. So that's virtual machines in Rumble Cloud. It's super easy. We will be showing you how to actually use this in another part of this course. But for now, this is just the basics. I will leave you with the summary and glossary. You can have a look before we go into the next section. Thanks for watching. See you in the next part. Lesson 4, we are talking about images. These are not Docker images. These are actually operating system images. So an image is a pre-configured template that contains an operating system and the necessary software to create the virtual machine. So instead of setting up each VM from scratch, you actually just use an image, which allows the user to quickly deploy new VMs with a consistent configuration because all these things are preset in the image. So using image just ensures that all VMs created from the same template have identical settings. All right, so making management is easier and deployment is faster. All right, so we can create a lot of different images from Linux, Android, Windows, and all the Linux distributions as well. So moving forward, let's go over a few key features of images. So what we have is reusability. So images can be used multiple times to deploy new VMs with the same configuration. So saving you a lot of time and saving you a lot of effort. Next up, we have customization. So users can create custom images with specific software settings and configuration tailored to your needs, to your application. You can remove any kind of unnecessary things you don't need in that image, save on space, save on RAM, save on CPU. It is up to you. Then we have portability. So your images can be shared across different environments. So this makes it easier to migrate and replicate configurations between development, testing, and production stages. You can ship those images to wherever you want, reuse them whenever you want. Then you have snapshotting. So running VMs can be captured as snapshots and converted into images for backup or disaster recovery purposes. All right. So looking at this chart here below, I realize there is a Docker container there. Just don't mind that. So we create our image, we create our base image, we customize it with all the settings that we want, we save it, and then we can deploy a VM with that. Once that is running, we have our VM instances to which we can create VM snapshots, all right? What are the benefits? So again, the benefits are consistency, speed, scalability, and disaster recovery. So consistency, we ensure that all of our VMs are uniform. All VMs deployed from the same image have the same configuration. This reduces errors and ensures uniformity across environments. Next up, we have speed. So you can quickly deploy these VMs. There's no need to configure each one. You accelerate the provisioning process to just a few seconds. Then you have scalability. So you can replicate these VMs. You can scale horizontally and meet demand of usage. All right. Finally, we have disaster recovery. So your snapshots and images facilitate quick restoration of systems in case of any failures, and this minimizes your downtime. So those snapshots and images can be used to restore your systems, quickly get them up and running for your clients and customers. Images in Rumble Cloud, all right? This is a big thing in Rumble, and there are a lot of offerings. So Rumble Cloud offers an image service that allows you to create, upload, store, and manage your own images for VM deployment. So the key features include pre-built images, custom images, you can version control them, and it also integrates with other services. So if you look here on the right, this is how it looks to create your own compute image in Rumble. You simply name it, or you can upload your own OS file. Here we select the disk format, the container format, and the OS version. So as you can see, there are a lot of Linux distributions. You have Windows, you have CentOS, Ubuntu, Fedora, Debian, anything you really want, Rumble has, all right? So by leveraging Rumble's cloud image service, your business can really streamline their VM deployment process and maintain consistency across their infrastructure. Just to wrap up the summary here, images provide a standardized and efficient way to deploy new VMs quickly and consistently. So by using images, your businesses can, first off, save time by avoiding manual configuration. 2, ensure consistency across deployments, reducing the risk of configuration errors. And 3, scale their virtual environments quickly to meet any changing demands. And then finally, 4, improve disaster recovery capabilities through snapshots and backups. So Rumble's cloud image service simplifies this image management, providing you the tools needed to create, manage, and deploy VMs from images very efficiently. Okay, so the last lesson in this module is operating systems. I just want to say, if you made it this far, I'm proud of you. Let's keep going here and learn something new. So operating systems. So an operating system is what manages a computer's resources, including its CPU, memory, storage, network, and provides the environment in which the applications run. So the server operating systems are specifically designed to handle multiple users and high-performance tasks efficiently. The operating systems essentially are for both physical and virtual machines. They are offering an interface for applications to interact with your hardware resources seamlessly. So if you look on the picture on the right here, these are all the different things that an operating system actually controls. So we have applications, input-output management, device drivers, such as your keyboard, your mouse, your webcam, your microphone, anything else. And then you have your memory management, which is your RAM, your CPU management, and your hardware. So this can be like your outside physical hardware. So moving forward, we're going to talk about the key features. So the first feature is multi-user and multitasking. So server operating systems support multiple users and allow several applications to run simultaneously. This ensures the efficient use of resources, all right? So it uses a CPU to run multiple different tasks. And that is managed by the operating system. It knows exactly how much CPU to use off, right? Then we have resource allocation. So server OSs efficiently distribute CPU, memory, and storage resources among various services and applications to optimize their performance, all right? So this operating system is very smart. It knows exactly how much CPU to use if we have different tasks. So if we have, let's say, 3 different tasks, that CPU or that OS will know exactly how much to split off. So maybe 10% here, 5% here, maybe this one needs 30%. It will efficiently know how much power to give to each one. Next up, we have security. So enhanced security features protect against unauthorized access, breaches, and malware. So this ensures that the integrity and safety of data applications. So your OS is able to protect you against these unauthorized accesses. So it will tell you if something is trying to access your storage, your CPU, or your RAM in a very malicious way. That is one of the biggest benefits, all right? Next up, we have network management. So the operating system provides tools for managing network connections, enhancing your security, and facilitating your data transfers across networks. So your operating system handles everything. So just to summarize quickly, you have your network management, your multi-user support, and your security all run by your operating system, which is smart enough to know how much storage, CPU, RAM, and network traffic it needs to allocate to your different services on your VM, okay? Now, moving on to the popular server operating systems. You guys may be familiar with a lot of these, or maybe this is the first time hearing it, but Ubuntu is renowned for its stability, security, and extensive support in cloud environments, making it a super popular choice for a lot of server applications. Then we have CentOS, which is a free, reliable version of RHEL, or Red Hat Enterprise Linux, which is widely used for web and cloud deployments due to, again, its robustness and community support. It's a very, very popular OS, which is also open source. Then we have Red Hat Enterprise Linux. Now, this one costs money. This one you need a key for. It's a commercial Linux distribution that offers advanced security features and comprehensive support stability for enterprise-level applications. So many big companies pay lots of money for this type of operating system. Then we have SUSE Linux Enterprise Server. So this one is known for its reliability and performance, especially in enterprise environments that handle heavy workloads and require high availability. Now, I haven't seen much use of this one in my line of work, but I've seen a lot of use of RHEL, which is the more popular one. Choosing your OS. So when selecting an operating system for your VMs in Rumble Cloud, consider the following factors, okay? Consider the compatibility. Ensure that the OS supports the software and applications that you want to run. So make sure your application is compatible with the OS that you are running. 2, security. Look for operating systems that offer robust security features to protect your data and applications. 3, support options. Consider the level of support and updates that are available for your operating system, all right? Is it community or is it enterprise? If your application doesn't require a lot of support, maybe go for some sort of community operating system. If you really do need maximum security and the most reliable support, go for an enterprise level operating system like RHEL or SUSE. Then we have performance. So choose an OS that can efficiently handle your workload requirements and optimize your resource usage. So select based on your workload's performance needs. Rumble Cloud, again, offers a wide range of operating systems, so you shouldn't have any trouble finding one that allows you to select the best fit for your specific needs and your use case. So just to kind of wrap up here, operating systems are vital for managing hardware resources and providing a stable environment for applications. Your server operating systems are tailored for multitasking, network management, and enhanced security, making them ideal for large-scale cloud environments. And Rumble Cloud offers flexibility by supporting these various operating systems, enabling your business to choose from the most suitable OS to meet your needs, your application needs, and your operational requirements to optimize your performance. So I'll leave you with the summary and glossary for now, and then we're going to head into the next module. All right, guys, welcome back to Module 2, where we will be talking about networking in the cloud. I'm just going to give you a rundown of the basic components of networking that you should know. We will not be designing network infrastructure in this course. We're going to be doing that in another course. So let's just start with nice and easy, lesson 1, IP addresses. So what is an IP address? An IP address is a unique identifier that is assigned to every device connected to a network. Similar to how a phone number identifies a phone, so just as phone numbers enable communication between people, IP addresses allow devices to communicate over the network. In cloud computing, IP addresses are essential for connecting your VMs and other services that you have out there on the internet. If you have a look at this diagram on the right here, this is how an IP address looks. Don't be concerned about the bytes and bits right here. I'll be showing you how to design subnets and pick and choose how your IP addresses should look in another course. For now, we'll just keep it simple. Just know what an IP address is. Next up, in cloud environments, there are 2 main types of IP addresses. The first being the fixed or the private IP address. So these are used for internal communication within your cloud infrastructure. Private IPs are not accessible from the internet and are typically assigned to your internal resources like databases or backend services that you don't want to expose to the internet. So a use case would be you might assign fixed IP addresses to your internal web servers and databases so that they can communicate with each other securely in the cloud without access to anyone else that's out there on the internet, right? The second one we have is floating or public IP addresses. So these are public IPs that allow external access to your cloud resources. So floating IPs can be moved between VMs, so you can switch them. And this makes them ideal for managing public-facing resources like web servers or other cloud services that you have that you want to expose externally. So a use case would be if you want a specific VM, like a web server, to be accessible from the internet, you would assign a floating IP address to it. And you can also remove that floating IP if you don't want that one and make a new one, and then just easily assign it back to that web server. So a use case for fixed and floating IPs right here. So again, it's pretty much just fixed IP addresses you can assign to your VMs and your databases that you want to keep secure. Your floating IPs are going to go to resources that you want to expose externally. So if we look at this diagram right here, just a nice, simple, easy one, you have your external user, you have your floating IP that is available to your external user. Then you have here your virtual private cloud. And what we've done here is we've assigned this floating IP to your NAT gateway. Don't worry about what that is yet. We'll touch on that in another lesson. But this is used for network address translation. And all we've done is just assign this floating IP to it. So when the user pings the floating IP is attached to the NAT gateway, and the NAT gateway will then route your request to one of these private VMs here. If you have a look here, these are private IPs. So your external user cannot communicate with these VMs. However, it can ping this floating IP, which goes to the NAT gateway, and then the NAT gateway routes all of your requests. So that's just an easy little overview of how that works. So how are IP addresses managed in Rumble, and how can you create them? So in Rumble Cloud, IP address management is very streamlined, and it gives you a lot of flexibility and security. So you have your fixed IPs and your floating IPs. You can easily allocate an IP from the network section in Rumble Cloud. You can create an IP very easily like this. You just enter what your network is if you've created it, the subnet that you've created, add a little description, click OK, and boom, you have your floating IP you can then assign it to whatever resource you want. So very simple, very easy. It's a lot more complex in some cloud services, but Rumble keeps it very simple for new users as well. So just to kind of summarize here, your IP addresses are fundamental for your device communication within your networks and the internet. So in cloud computing, understanding the difference between fixed and floating IPs is very crucial for managing your connectivity between your services and the security. So just to recap, fixed IPs enable secure internal communication. Floating IPs allow external access to your resources, and you can reassign them as needed for flexibility and scalability. So Rumble Cloud really simplifies IP address management by automating fixed IP assignments and providing easy control over your floating IPs. So this just ensures that your virtual machine is both accessible and secure, allowing you to effectively manage your cloud resources. So I'll leave you with the summary and glossary. You can have a look before we go into the next lesson. Thanks for watching. See you in the next lesson. Okay, lesson 2, we're just going to do a little bit more of a deep dive into floating IPs. So just to recap, floating IP is a public IP address that you can dynamically assign to any VM or a resource within your cloud infrastructure. So it serves as an entry point for external access, allowing all those internal services to communicate within your network and with anything outside on the internet. So they're essential for things like servers that need to be reached from outside. So let's just go over the key features here. So the first feature is dynamic assignment. So floating IPs can be assigned or reassigned to different VMs without altering the internal network configuration. So this flexibility allows for really a seamless transition between VMs. If a VM needs a new IP, you can simply create a new floating IP and assign it one. Then you have external access. So VMs with floating IPs are accessible from the internet, enabling external users to interact with your services that are hosted on these VMs or other services that require an IP address. Finally, we have reallocation. So if a VM needs to be replaced or updated, the floating IP can be moved around to the new VM. So this minimizes downtime and ensures continuous availability for your service. So an example can be like when you're updating a web server, you create a new web server, and then you can just transfer that floating IP from the old server to the new server without disrupting user access. So this is an instant change that wouldn't affect your application. Quick use case here, you have web servers. So again, you can make your web servers accessible to external users. You have app servers. You can make your applications allow clients to use your APIs from outside of your network. And then you have reallocation. You can quickly reassign IPs if you want to replace certain VMs or update VMs. So if we look at this diagram again, it's very simple. You have your external users again, your floating IP in front, and then this floating IP just points to a VM in your private network, which communicates to other internal services within your network. So remember, the external user cannot directly access these. They have to ping the floating IP so that they can have communication with anything in your private network. So the best practices for floating IPs. So the first one is limit usage. Your public IP addresses are a limited resource. So assign floating IPs only to the VMs that require internet access so that you can optimize your usage. You have enhanced security. So protect your VMs with floating IPs. You can use firewalls and security groups. We will touch on these two things in further lessons. This allows you to implement strict access controls so that you prevent any unauthorized access. Then you have automate management. So use automation tools to manage floating IP assignments. This ensures consistency and reduces the risk of manual user errors, right? Then you can monitor and audit. So you can regularly monitor the usage of floating IPs and audit their assignments to maintain security and operational efficiency. And finally, we have plan for scalability. So design your IP allocation strategy beforehand so that you can accommodate any kind of future growth. So you have to ensure that you have enough floating IPs available to handle your scaling needs, okay? Floating IPs in Rumble. So Rumble Cloud offers a lot of tools for managing floating IPs effectively. So you have IP pool management. You can access a pool of available public IPs that can easily be assigned to VMs as needed. So these are available. You can immediately assign them very quickly, very easily. Easy assignment and reassignment. Assign or reassign floating IPs through the Rumble Cloud dashboard. Very simple. You can just do it right from the dashboard or API calls if you are writing code. Then you have integration with load balancers. So load balancers we'll touch on later, but this allows you to combine floating IPs with load balancers so that you can distribute traffic efficiently across multiple VMs. And this, again, just enhances your performance and reliability. If you have a load balancer right here, and then you have a bunch of VMs, you can assign a floating IP right there, and then this load balancer will just manage the traffic to those VMs. Then you have security features. So you can utilize the built-in firewall rules and security groups to control access to your VMs with floating IPs. You ensure that they remain secure, that they are only accessed through that one point of entry. And finally, you have your monitoring tools in Rumble Cloud. So you can track the usage and the performance of floating IPs with Rumble's monitoring tools. This allows you to proactively manage and troubleshoot any kind of issues that are in your VMs or your network. So again, floating IPs are crucial for enabling external access to your cloud resources. They offer the flexibility by allowing you to dynamically assign them and reassign them. And this ensures that you are highly available so that you are resilient and can recover from disaster. And floating IPs just allow you to minimize that downtime. So just remember that they have dynamic assignment, they allow for external access, and to use the best practices when using your floating IPs. So Rumble Cloud really simplifies floating IP management with the tools for easy assignment, security, and monitoring. This helps your business to really maintain reliable and secure external and internal access to your cloud applications. So I'll leave you with the summary and glossary. You can have a look before we hop into the next lesson. In this lesson, we're just going to go over virtual private clouds. If you don't know what that means, it's okay. I'll just give you a very quick rundown, but basically you just have to know what it is. We won't be actually building out a virtual private cloud in this course. So simply put, a virtual private cloud is a dedicated section of the cloud where you can securely manage your resources, all right? So this provides you with isolation and allows you to control how your resources communicate internally and with anything on the outside, all right? So it is your own private cloud where you have all of your resources and it is not accessible to anything external on the internet. So VPCs give you the flexibility to design your own network, and similar to how you would set up a traditional on-premises network, but in the cloud you have scalability and reliability of the cloud. So you have a lot less management here. So the key features of a VPC, the first one is isolation. So this keeps your resources secure and separate from other cloud environments. This ensures that your data and applications remain private and in your own network. Then you have customizable networking. So a VPC allows you to set up subnets, define IP addresses, define the ranges, and configure routing rules tailored to your specific needs. So you actually control how data goes in and out of your VPC. That's what makes them so powerful. It's your own dedicated cloud. Quickly, I'll go over what subnets and IP ranges are. So subnets allow you to divide your VPC into smaller, more manageable networks, okay? You can have a public-facing subnet or a private-facing subnet for your internal resources. So anything on the public subnet will have a public IP address that you can access from externally, and anything on the private you can access from within your VPC. So your private subnet can communicate with your public subnet through some kind of gateway or directly if that's how it is set up. Then you have IP ranges. So you can allocate specific IP ranges for your VPCs. This just ensures that your internal resources can communicate effectively if they are within the same range. So let's say you have 175 and 000. If you create this range from, let's say, 175.0.0.0 to like 10, so this is your range for that subnet. So you have maybe like 10 IP addresses available. So you can only have about like 10 resources. So that's why designing your network is very important. We won't be going over that now because it's a bit more complex and just a bit out of scope for this course. Just understand that that's how it works. You set up ranges for your subnets, and those are the set amount of IPs that you can use, all right? So the benefits of using a VPC, you have enhanced security. You have complete control over your security settings. That's your firewalls and your security groups, so you can control the traffic going in and the traffic going outside of your VPC and your subnets. You have scalability, so you can easily scale resources like your VMs within your isolated VPC environment, all right? Then you have custom routing. So again, you can just define how traffic goes in and how traffic moves out. You can block certain IP ranges. You can block certain IPs. You can just blacklist them from entering your VPC. And that's very important if you run into issues of maybe someone trying to DDoS your web server, you're going to want to set up custom routing rules. So in Rumble Cloud, VPCs provide an isolated environment for deploying and managing your resources. You have a lot of features such as subnet configuration, routing rules, security groups, and firewalls for security controls. You can establish connections between your VPCs or other on-premise networks. And then you also have monitoring and management, so you can utilize those integrated monitoring tools to see if everything is working well, if traffic is good. And it's very simple in Rumble Cloud to create your own VPC. You just got to know what you are designing, but this is the dashboard where you can create your network. So I'll just leave you with the summary and glossary, and we can get into the next lesson. Lesson 4, we'll talk about networks. We'll do a little deeper dive, and it'll probably give you a better understanding of how VPCs work and everything that goes into a VPC. So what are networks? So networks are virtual environments that allow your resources to communicate with each other and with the external systems. So they're essential for securely and efficiently connecting virtual machines, databases, and applications within your cloud infrastructure. So by leveraging those cloud networks, businesses can ensure easy data flow, enhance the security by isolating their resources, and optimize performance by controlling how resources interact both internally and externally. So if we have a look at this diagram here, we can see that we have a private and public cloud networks. So our private network is split up into 2 subnets here, which contain services, which contain internal VMs, and all of these things are funneled through a NAT gateway, and that's the only way they can be accessed by anything externally. And we would have a floating IP with some routing rules that point you to the proper subnets. Up here, we have a public network that contains a public subnet, which contains a public subnet, and these servers are accessible publicly, and anyone from the internet can access this load balancer. This load balancer can also have a floating IP right in front, which can allow any kind of user access into these services that are in your public subnet. All right, so that's how that works. Let's go a little deeper into the key components. So you have private networks. So this is used for your internal communication between your resources. The networks are not accessible from the internet. So this ensures that your sensitive data and applications remain secure and within your cloud environment. All right. Then you have your public networks. These are accessible externally. So you can expose your resources to the internet via floating IPs, load balancers with a floating IP. And these are essential for services that need users to access those resources. Next up, we have subnets. So you probably saw this earlier in the VPC. If you don't know what it is, I'll explain it in a bit more detail right now. So subnets simply just divide your network into smaller, manageable sections, all right? And these are called subnets. So they help you organize resources, control traffic flow in and out of your subnet, and enhance security by isolating different parts of your network based on your functionality and requirements and the way that you have designed your public and private clouds. So here we have a private network and a private subnet. So this private subnet has some kind of IP range and a set number of IP addresses. That means you can only have a set number of resources, right? So in this case, let's say we have 10 IP addresses. We can assign 10 IP addresses to 10 internal VMs and services, and then point those out to a floating IP address if we want to access them. Then we also have the public network, again, public subnet, external, and that just points outside into the internet, right? So network management in Rumble, you have isolated networks. So each cloud project has its own private networks, and this ensures isolation between your resources, okay? And then you have internal and external communication, as we talked about, private networks for internal, public networks for external through floating IPs. I'm just going to backtrack here. I just want to quickly talk about route tables. So route tables allow you to define the paths that network traffic takes between within your VPC. So route table controls how your data moves between subnets. All right, so it elicits communication between your subnets, and this just ensures efficiency and secure communication. The next thing I want to talk about is gateways. Okay, so you have internet gateways and you have NAT gateways, okay? So your internet gateway allows communication with anything that is external, all right? And this enables instances with public IPs to access the internet and also receive any kind of incoming traffic, okay? So remember, internet gateway external, and then you have your NAT gateway. So your NAT gateway enables instances in a private subnet to connect to the internet or other services while preventing the internet from initiating connections with those instances. So this is more of an internal sort of control. All right. So that's just a quick little overview on that. So network management in Rumble, again, we just covered that. So I'll leave you with the summary and glossary. You can have a look at this before we go into the next lesson. I hope that clears up some of the earlier things. I know we did VPC first, but it's important to understand what a VPC is and then understand the internal workings of what actually goes into creating a VPC. So thanks for watching. We'll see you in the next lesson. Lesson 5, we'll be talking about ports, and ports are very important to control the kind of traffic that you allow in and out of your services. So what are ports? So ports, simply put, act as a gateway that allow data to flow in or out of your virtual machines within a network. So each VM has multiple ports to send and receive data, and this allows communication both within the internal network and with external resources. So this is an analogy that might help you understand ports a bit better, but think of ports as doors on a house. So each door allows specific types of traffic or data to enter and leave. So functionally, ports help direct traffic to the appropriate services or applications running on a VM, and this ensures efficient and organized communication. So if we have a look here at this diagram below, there are different kinds of doors that we have. So let's say port 443 is always assigned to HTTPS, port 80 is always assigned to HTTP communication, and port 22 is for SSH. So this VM has all of these ports available. You can also have different kinds of ports, like let's say port 500 or something, if you want to assign that to some sort of a service that is running on your VM. If you want to access this service, you would maybe have to just call this sort of IP with that specified port, and then your traffic can enter through that door, using that analogy, right? So very simply put, it just acts as a door and allows traffic in and traffic out, depending on what your specifications are. So the key features of ports. So ports offer attachment points. So ports connect VMs to various networks, and this allows communication between different parts of your infrastructure. So each port has its own unique number or IP address, and then you can use that to connect to anything, right? Ports allow security. So ports can be linked to security groups, and this allows you to control inbound and outbound traffic. So security groups, simply put, just block certain type of traffic or allow a certain type of traffic into your network, all right? So this is a very important feature for security. Finally, we have stateful versus stateless. Now, in Rumble Cloud, this applies more to security groups, but it's very important to remember what these definitions mean. So stateful ports allow you to track the state of active connections, and it allows return traffic automatically. So if it was allowed once, it will be allowed again. All right. Now, stateless ports, they do not track connection states. So they require explicit rules for inbound and outbound traffic. So if I request to enter through a port and it allows me, cool. If I want to do it again, I have to do it again. There is no connection state being tracked, so I will have to be authenticated again. All right, so just remember these key features of ports: attachment points, security, and stateful versus stateless. These definitions will come up again in the security groups section. In Rumble Cloud, we can configure and manage our ports, so it provides a lot of tools for doing so. Automatic port creation. When a VM is launched, the necessary ports are automatically created based on your predefined templates or configurations. Then you have manual configuration, so users can manually open, close, or modify ports to tailor network access according to your specific needs. So if you have a service running on port 400, you have to manually expose that port so you can allow traffic into it. Then you have security groups integrations. Again, we'll touch on these in a later lesson, but you can assign security groups to ports. It allows you to define rules, allow or deny traffic based on IP addresses, protocols, and port numbers. All right, so you can block access, you can allow access. That's what security groups are for. They act as a firewall for your network. Port forwarding. So you can configure port forwarding to redirect traffic from one port to another. if I want to access some service on port 400, I can have a redirect in there to push me to port 500. So this allows complex network setups and service accessibility throughout your network. Monitoring and alerts, you can monitor port activity and set up alerts for any kind of unusual or unauthorized attempts to access your network. So this just enhances your security oversight. You can see who's coming into your network, who's coming out, right? And finally, your automation and APIs. So you can utilize Rumble Cloud's APIs to automate port management tasks. This ensures consistency and reduces any sort of potential manual errors when configuring your ports, and also just kind of allows you to keep track of what's being opened and what's available. Port management in Rumble Cloud. So if you look down here, the create virtual adapter, that's what it's called in Rumble Cloud. This allows you to create virtual adapters to expose certain ports. If you look here again, you have your security groups. If you look down here, you have your security groups. So you can assign different types of security groups to allow and deny certain traffic. So just to recap, you have automatic port creation. So your ports are automatically created when launching new VMs. You have custom ports. You can manually create and manage ports, configure them for specific network and security needs. And some of the best practices for port management that you should follow is least privilege principle. This is a very important one. Only open the ports that are absolutely necessary for your applications to function. This just minimizes potential attacks to your services. Don't expose any ports that you don't need to. Do regular audits. So review open ports and associate security rules to ensure that they align with your current security policies and operational requirements. So it's important to keep track of these things so you know what is exposed to the internet, so you know what is not exposed to the internet. Yes, just keep regular audits, do regular audits, and documentation on this. And finally, use strong security groups. Define clear and strict security group rules so that you can control access. Specify allowed IP ranges, protocols, and port numbers so that you know what is going in and out of your VMs and services, all right? So just to summarize, ports are essential components that enable communication between your VMs and your systems within the cloud network. So quick key aspects are your attachment points, your security control with security groups, IP address associations, and protocol management. You can handle different protocols with these port numbers. Effective port management in Rumble Cloud ensures that your application is both accessible and secure. Follow the best practices like least privilege, regular audits, and leveraging your automation so that your businesses can maintain robust and efficient network infrastructure. Rumble Cloud's port management tools provide you with a lot of flexibility and control needed to optimize network traffic, enhance security, and support scalability of your cloud-based applications. So I'll leave you with the summary and glossary. You can have a look at that before we get into the next lesson. Thanks for watching. See you in the next lesson. In this lesson, we'll touch on routers, and routers are very important for controlling the traffic flow of your network. So what are routers in cloud networking? Routers are devices that connect different networks and direct traffic between them. So in cloud environment, routers play a really crucial role by enabling VMs and private networks to communicate with external systems or other internal systems and subnets. So the functionality of a router, it determines the best path for your data to travel from one network to another, and it just ensuring efficient and reliable communication, all right? So a quick analogy is, think of routers as traffic directors that manage the flow between various roads, which is your networks, and ensuring that information reaches its destination without it being congested or without it being blocked. So if we have a look right here, we have a router set up between this external network and this internal network, and this router simply just controls that traffic flow. All right, now we can also put this right here between the floating IP and the NAT, and we can point it to different subnets based on the routing rules. If someone has, let's say, /API, and then like another route, we can point that to somewhere else, right? So very simple, they just direct the flow of traffic within your network. Key functions of routers, so connecting networks. So routers enable communication between private networks and the internet, facilitating data exchange between internal resources and external users or external resources. So they just link different things together. Then we have NAT, so network address translation, We've seen this a few times up until now, but haven't really dug into it. So routers convert IP addresses used within your cloud infrastructure into public IP addresses for external communication. So NAT allows multiple VMs to share a single public IP, and this enhances security and like the communication between your IP addresses, all right? So it just ensures communication with external services. If you remember a few of the diagrams below, we had a NAT like so, and then this was pointing to 3 different or 4 different or however many different services, and then we had a floating IP. So this NAT just controls that flow and tells you where to go. Quick touch on floating IPs and routers again. So routers just enable the use of floating IPs for public access, and it allows your external services to reach cloud resources by routing the traffic to the appropriate subnet. So it is just like a traffic director, tells you where to go, simply put. The best practices for router configuration, there is a lot, but we'll just do 2 for now. We have redundancy. Use redundant routers to ensure continuous connectivity and avoid single points of failure, okay? We want to be ready for any kind of disaster recovery, so we should have routers set up for that case. Then we have traffic monitoring. So this will monitor routers to detect unusual traffic patterns or potential unauthorized access or any kind of attack on our internal network. So it's very important to implement strong security measures when planning your networks and your routers. Routers in Rumble Cloud. So in Rumble Cloud, you can easily configure routers, again, to manage the traffic between your subnets and the internet. Rumble Cloud supports NAT, route tables, and floating IP configurations. It's very easy to create a router in Rumble Cloud. This is how the dashboard would look. You put your name, your description, you pick which subnet you are in, and you can also attach it to a public network if you have a public network. If you have a private network, it will go into your private network. So in summary, routers are just essential components in your cloud network that allow for communication between different networks and managing your data traffic efficiently, all right? So the best practices that you want to remember for routers is optimize your routing rules for efficiency, implement strong security measures to allow traffic in and out, and regularly update and monitor router performance, and finally just plan for scalability and maintain configuration backups of your routers so that you can rebuild if anything does happen. So Rumble Cloud simplifies router management with easy dashboard setup or automated setup, customizable routing rules, seamless integration with your floating IPs, and a lot of monitoring tools. So by following the best practices and leveraging Rumble Cloud's router management features, your business can build secure, efficient, and scalable cloud network infrastructure for your needs. So I'll leave you with the summary and glossary, and we'll get into the next lesson. Thanks for watching. The final lesson in Module 2, we'll be discussing load balancers. So load balancers distribute incoming network traffic across multiple servers so that no one single server becomes overwhelmed. And this distribution enhances your reliability and your performance of your cloud applications by balancing the load effectively. All right. So as we see in this diagram here, we have 3 clients. All right. Now we have a load balancer here and we have 4 servers. If we had about 10 more clients, this load balancer knows exactly where to route these clients. So if one client is finished here, it'll route another one to that server. All right. So it knows how to distribute your traffic evenly across multiple servers. And this is really, really good for resiliency in case of disasters. All right. The key functions, actually, I just want to give you a quick analogy before we go further in case you are a bit confused. Think of a load balancer as a traffic cop. So a traffic cop is directing cars, and in this case, your cars are requests to different lanes or servers to prevent any kind of traffic jam or server overload, all right? So just picture a cop right here, and he's just pointing people in the right direction so that there is no traffic jam if there are way too many requests coming in from users. The key functions of load balancers. The first one being traffic distribution. So load balancers distribute your outgoing traffic across multiple virtual machines. And there are various algorithms that go into this. There is round robin, there is least connections, and there is IP hash. So you don't have to really memorize these. I'll just quickly define what they are. So round robin, in this case, just cycles through the servers in order. So it just goes in a cycle and picks the one that is empty and then just goes back to the beginning, right? Then you have least connections. Least connections directs traffic to the server with the fewest active connections. So if there are 5 connections here, 2 connections here, 1 connection here, the next request is going to go to VM3 because it has the least connections, all right? This is very different from round robin, where in round robin, it'll just go here, then here, then here, and then back again to VM1 and just keep routing in that cycled loop, right? The final one we have is IP hash. So IP hash. Now, IP hash routes traffic based on the client's IP address. So let's say you have some sort of IP ranges set up here. If they fit within that rule, they will go here. If they fit within another rule, they will go here. And finally, the third rule, they'll go here. All right, so that is IP hash. Again, you don't have to memorize the routing rules. It's just a quick little piece of knowledge that may come in handy sometime. Then the second key function we have is health monitoring. So continuously checks the status of VMs to ensure that they are operational. If a server becomes unresponsive, if a server fails, the load balancer knows this and automatically reroutes the traffic to healthy servers so that it can maintain that application availability. So here we have monitor health. These are health checks, and they may check a certain path. Usually that path is something like /health if you are running APIs. If this one, for example, goes to shit and breaks, the load balancer knows, okay, this one's gone, this connection is dead, I'm going to bring you here, or I'm going to bring you here. All right, so it's very smart, and it knows where to take you. Another key function we have is session persistence, or sticky sessions, maybe known in... Another key feature we have is session persistence, or sticky sessions, as we may have seen in other cloud services. This feature ensures that a user's session remains connected to the same server throughout their interaction. So this is crucial for applications that require consistent session data, such as shopping carts or user dashboards, where you need to be constantly connected. So session persistence just keeps a user's session connected. Very important for stateful applications where your data needs to be retained. All right, so just keep that in mind. Then we have the types of load balancers. Now, there are many, but I'll just cover 2 of them right now. We have a layer 4 load balancing. This operates at the transport layer, and it manages traffic based on IP addresses, or known as TCP, UDP connections, or UDP ports. So this is ideal for simple, high-performance load balancing where deep packet inspection is not required. We won't be touching on packets. This is more networking. This is going to need a deep dive, so I'll just mention this now, and you can do some research later if you want. Then we have layer 7, which is your application layer. This functions at the application layer and allows for more complex routing based on your HTTP headers, all right, or your URLs, your cookies, and other application-specific data. So this is suitable for your web applications that require intelligent traffic distribution, such as routing requests to different microservices if you have multiple different API-like routes, right? So that's what layer 7 does. So load balancers are critical for ensuring the reliability and the performance of your cloud app by distributing traffic across those multiple servers. Just to recap, right? So you have your traffic distribution, your health monitoring, and your session persistence that are your key features. And Rumble offers very easy load balancer creation. There are a few steps that you have to go through here to create one. This is just your base configuration, where you are going to be placing your load balancer, what your listener is doing. Your listener is just something in front of your load balancer that listens for oncoming requests on a certain port. So for example, if you have an HTTP application, you'll pick the port, I believe it was 443, and that will route your requests. So that is the port that it will be listening on, and you have a floating IP in front of that, and the listener at the end there. So to summarize, Again, remember the key features of a load balancer. Know what a load balancer is, and you shouldn't have too many issues. A few best practices that we didn't have in the slides, but that are, appropriate to note that you should know. You should select appropriate load balancing algorithms if available based on your application needs. Make sure to also implement health checks so that your load balancer knows when a VM is down, when it is failing, so that you can route that traffic properly. Secure your load balancers with proper security measures, and also just continuously monitor and optimize load balancer performance. That's very important to always monitor your load balancers because they are the gateway to your application, all right? And Rumble's Cloud's load balancing solution provides your tools and flexibility needed to manage the traffic effectively. It will ensure that your application remains responsive and available, and with you following the best practices, you should have a very good application where your business can achieve a scalable, secure, and high-performing cloud architecture. So I'll leave you with the summary and glossary. You can have a look at that before we get into the next module. Module 3, we will be discussing cloud security. There are 3 components to this. There are your key pairs, your SSH, and your security groups. So this first lesson, we'll talk about key pairs. If you don't know what key pairs are, they are essential for securely accessing any cloud resources using your public and private keys. So think of them as the keys to your cloud kingdom, all right? A key pair consists of 2 keys. You have your public key and your private key. So your public key is stored securely on the cloud instance and can be freely shared. Then your private key is kept securely on your local machine and must remain confidential. When you connect to your cloud instance, the system verifies your private key against your public key, and this method ensures secure access without showing any sensitive information like passwords over the internet. So it's just a key with a jumble of letters that lets you access your cloud resources. This diagram here will actually discuss a little bit more detail in a couple slides. So let's get to the key components of key pairs. So your public key is stored on the cloud instance. The purpose of it is it's used to authenticate the corresponding private key. And you can freely share this without compromising security, all right? Then your private key. Now, your private key is kept secure and secret on your local machine, and this is used to access and authenticate with cloud instances. You must be protected to prevent unauthorized access, so you must protect this private key, all right? Keep this secure as much as you can. When you connect to a cloud instance using SSH or Secure Shell, the server uses the public key to verify the authenticity of your private key. So this process ensures that only authorized users can access the system with all of the communication encrypted for added security. So how does it work in a bit more detail? So when you attempt to connect to a cloud instance, the server checks if the private key matches the public key. If they match, the access is granted, you are authenticated, you can do whatever you want on this server, all right? Within this, we have encryption. So the data sent between your machines and the cloud resources is encrypted, and this ensures secure communication. So let's just run through this one last time. So your client initiates a connection with the server, all right? The client holds the private key. The server verifies the client's private key using the public key. If they match, if everything is all good, the authenticated connection starts, all right? Your client is authenticated, they can do whatever they want. In Rumble Cloud, we have flexible options for managing your private keys. It is a very simple, very easy, really bare bones process to creating key pairs or importing key pairs, all right? So creating your key pairs, you can create a completely new key pair in Rumble Cloud through the console or the CLI. If you do it through the console, through the dashboard, you create it, and then that key pair is automatically downloaded, all right, and saved locally. If you want to import a key pair, you just upload an existing public key to Rumble, and this allows you to SSH into instances without generating new ones, all right? You can use your old key pairs. So this is how a key pair looks. This is the public key. Again, does not matter if you see this. As long as you don't share your private key, everything is all good. The best practices. So it is very important to back up your private key. Securely store copies of your private key in multiple locations so that you have access to them. And if you are locked out of an instance, you can backtrack and find that private key. Without your private key, you are not accessing anything. Okay, so you must have your private key. Rotate your keys regularly. This is very, very important. If you are not rotating your keys regularly, this makes you subject to attacks and risks that can compromise your cloud infrastructure, giving anyone access to your instances or your services. So remember to regularly rotate your key pairs as much as possible, within reason, obviously. And finally, limit access. So only share your private key with trusted individuals or systems. Don't be handing them out to anyone you don't want access to, right? Or they will have access to everything. So keep them close to you, limit the access. Very important to know this. So just in summary, very short, key pairs are fundamental for your security mechanism to access cloud resources. So they consist of a public key stored on the cloud and a private key kept on your local machine. All right, so you have your public key and your private key. Your public key authenticates your private key and can be shared freely. Your private key remains confidential and is used to access your cloud infrastructure. All right, just to summarize the best practices: back up your private key to prevent losses, rotate your keys regularly, limit access to trusted people only, and protect your private key with strong security measures. All right, so just make note of that. I'll leave you with the summary and glossary to review, and I will see you in the next section. Thanks for watching. Lesson 2, we will discuss Secure Shell, or in short, SSH. So SSH, or Secure Shell, is just a protocol that enables you to securely access and manage your remote systems and virtual machines in the cloud. So SSH encrypts all communication between your local machine and the remote system, making it nearly impossible for anyone to intercept your sensitive data, right? SSH ensures that all the data that is transmitted is encrypted, and it protects it from eavesdroppers. It's reliable, so it maintains that secure connection over a long period of time. And it's widely used for managing cloud-based servers, performing administrative tasks, and transferring files securely, all right? So let's have a look at this diagram here on the right, which will run you through the SSH communication flows. So if you remember, you have your private key on your machine. You do a command to initiate that SSH connection. From there, it will check the public key and verify it, all right? If you are not authenticated, so your private key and your public key don't match, nothing will happen. You can't connect. If you do get authenticated, it will establish that connection, and from there, you can access that VM, transfer data, really do anything you want on that VM, all right? So that is the flow of SSH connection. Few key features of SSH. One is encryption. So all data that is exchanged between your machine and the remote system is encrypted, ensuring confidentiality and integrity. Then you have authentication. So SSH supports both password-based and key-based authentication. Key-based authentication, which uses the key pairs, is the preferred method for enhanced security. However, depending on the users of the VM, you can also just input the username and the password and still connect to your VM, all right? A couple of SSH commands and their usages. The basic SSH command that you will use is SSH-I, input your private key, enter the user and the server IP address or name, all right? And this will allow you to connect your local machine to the remote server using your private key, so you have access to that VM. Now, the file transfer using SSH, you have secure copy protocol and SSH file transfer protocol. We won't get into these right now. However, they are protocols that are used to transfer files from one machine to another. To give you a quick example of how this might look, so the command for SCP would look something like this. So you have SCP-I, your path to your private key will be right here, .pem, and then the file that you want to transfer. And right here, you will put your user at IP address, and then your remote server path. All right, so the path where you want to put that file will go right here. So just folder, all right? So that is how SCP is done. Don't worry about that right now. That's for another course where we dive into the commands and how to use Rumble Cloud APIs and all that. So using SSH in Rumble, you can connect to your Rumble instances. After you create a VM in Rumble, you can use SSH to connect to it securely from your local machine. You do not have to do it from your dashboard, all right? And then your SSH with key pairs, use your private keys to authenticate with the public key stored on your cloud instance. The best practices for SSH security, you had user key-based authentication. Obviously, as we've talked about, it's preferred over username and password. It's a lot harder to crack and eliminates the need to transmit passwords over the network. You can change the default SSH port, considering changing it to reduce the chance of automated attacks. You can also disable root login. So as you launch a VM, you'll always have a root user. If you disable root access, you can only then authenticate through the users that you have created with the root on your VM. So it's a lot more secure, and it's standard to do this. In summary, SSH is just a protocol for accessing your cloud-based systems. It allows for security, convenience, and the key-based authentication provides really a secure method for verifying your identity without relying on usernames and passwords, all right? Just remember the best practices. Always use your key-based authentications. Change a port if you want to reduce exposure. Disable root login and protect your private keys. You can also put passphrases on these keys to restrict access. And Rumble Cloud allows for secure SSH connections by supporting this key pair management and providing you tools for easy VM access. If you adhere to the SSH best practices, you can ensure that your cloud resources remain secure and efficiently managed. So I'll leave you with the summary and glossary. That was a lot of information, so just make sure to review that before we go into the next lesson. Thanks for watching. See you in the next lesson. All right, y'all, we are on the last lesson of Module 3, and it is probably the most important one. This is security groups. Security groups in the cloud world are virtual firewalls that control your traffic. They allow what enters and what exits your instance. So they enable you to define specific rules for both inbound and outbound traffic control. This ensures that only necessary communication is allowed while blocking all the other traffic, all right? You have inbound rules, outbound rules, and stateful filtering. So your inbound rules define the types of incoming traffic that is allowed to reach your instance. Your outbound rules specify the types of outgoing traffic that is permitted. And stateful filtering automatically allows return traffic for established connections. So this simplifies rule managing by allowing connections that are already secured to enter back, right? So here's an example. You have your security group in your private network, and then you have your incoming traffic here and your block traffic here. Your incoming traffic is allowed, and your block traffic is something that you have blocked. So it can be a certain range of IP addresses. You're blocking a certain port into your VM. That's simply how it works, all right? So the key features of security groups, the first one being inbound and outbound rules, as we talked about in the last slide. It just defines what traffic is allowed into and out of your instance, and it's controlled based on IP addresses, the protocols, and the ports, all right? Then you have your stateful filtering, which automatically just allows your return traffic for allowed inbound requests. So applying security groups to instances, you can apply security groups at the instance level, and this controls in and out traffic within your network. You can apply it to multiple groups, so you can apply more than one security group to an instance, allowing you to create a really layered security, all right? So again, you can block IPs, you can block ports, and yeah, just allow in and out traffic from your security groups. The security group best practices. So the first one being the most important one is the principle of least privilege. Only allow the minimum necessary traffic required for your application to function. Avoid opening unnecessary ports and allowing unnecessary IPs, and restrict that access just to the trusted IP ranges, all right? Use different security groups for different roles. So group your instances by function. For example, you have web servers and database servers, and create separate security groups for the web servers and database servers, all right? Do regular audits of your security groups. So periodically review your security group rules and ensure that they align with your concurrent security policies and standards and operational needs. All right. Yeah, it's very important to do that so you're on top of your security policies. Managing security groups in Rumble is, again, super easy as it is in a lot of different cloud service providers. You have a console, or you can do it from code or APIs. So console management, you can use a dashboard to create, modify, and assign security groups to your instances. It's a nice, easy visual interface for easy configuration of your inbound and outbound rules. You also have a CLI where you can manage your security groups programmatically using Rumble's APIs for automation and scripting. And this is ideal for integrating security group management into your deployment workflows, all right? So you can use Rumble's API, and it also enables integration with third-party tools and custom applications for easy security management, okay? You also have security group templates, so you can leverage predefined templates for common security configurations to really streamline your setup, and those customized templates can fit your security requirements for your applications, all right? So as we can see here, this is the Rumble Cloud dashboard for the security group. If you have a look, we have different rules here. So we have ingress, egress, egress, ingress. So ingress is traffic going in, egress is traffic going out, all right? You have your IP protocol, and you have IPv4 or IPv6. Now, IPv4 is still used today, but eventually we transition to IPv6 because we are running out of IPv4 IPs. So it's very important to note that, depending on your application, usually we still use IPv4. Your remote, so this is just the types of IPs that you're allowing. So this is the standard notation for IPv6, and this is the standard notation for IPv4. 0000/0 just means that any IP is allowed. Again, you can change this so that it is not 000. You can actually just change this to just to allow this sort of IP range. You can create rules. You can create as many rules as you really want, depending on your security needs. So if we scroll down here a bit, we have the create a rule. So this is how it looks in Rumble. You can define your protocol, your TCP or UDP, whatever it is, the direction in which this rule applies to. So if it's ingress or egress, the type, so your IPv4 or your IPv6, your port type, it can be a range of ports, it can be a custom port, or it can be the default sort of 80 ports that most applications run on. And then you have the source. So your source can be all traffic, it can be a prefix, it can be specific IPs. Also to note that you do have a quota. With the base, you have a quota of 5,000 or 1,000 security group rules. So that's Rumble Cloud security groups. It's very simple, very easy to use. It's very easy to manage security groups in Rumble Cloud, as it is with a lot of other cloud service providers. So just to recap, security groups are essential for protecting your cloud resources to control inbound and outbound traffic. A few key aspects that you should remember is that you have default and you have custom security groups. Once you create a project in Rumble, you will have a default security group, but you will want to make your own custom one if you have applications that require custom inbound and outbound rules. Remember, there is also stateful filtering, so you can automatically manage return traffic, and this just simplifies your rule configurations. Remember to apply the best practices, so principle of least privilege, organize your resources by roles, conduct regular audits, and use descriptive names and implement logging and monitoring into your security groups. So Rumble is very easy. You can effectively manage your security groups in Rumble Cloud to ensure that your application remains secure, minimizes exposure to potential threats from the internet, and you allow necessary communication for your cloud infrastructure. So I'll leave you with the summary and glossary so you can review, and we'll see you in the next module. Thanks for watching. Welcome back to Module 4, Automation and Management. We have 3 lessons in this section. We'll talk about cloud automation and orchestration for this first one, and then we'll dive into the command line tools available and Linux commands that you should know for managing your virtual machine instances. So let's hop into cloud automation and orchestration. Cloud automation involves using software tools to handle various tasks involved in managing your cloud infrastructure. Think of it as setting up self-driving cars for your cloud systems. Once configured, the automations handle tasks like provisioning resources, scaling applications, and monitoring performance without any manual intervention. So we have resource provisioning, which automatically allocates and configures resources based on the demand. So if there's high usage, it may create another instance to account for that, right? So that your users can have a smooth, seamless experience. We have scaling applications. So we adjust the number of instances, like I just said, for running your application to meet the current needs or the usage percentages. Then we have performance monitoring. So you can continuously track the performance of your applications in infrastructure to ensure that it is optimally running, right? So that your users, again, have a smooth, seamless experience. Then we can dive into orchestration. So this kind of goes off of Kubernetes. So orchestration builds upon automation by coordinating multiple automated tasks to work together seamlessly. So imagine conducting an orchestra. Each instrument, in this case, your automation task, plays its own part, while the conductor, the orchestration or the command control center, ensures everything harmonizes perfectly and everything works together perfectly. So we have workflow coordination. It manages complex workflows that involve multiple automated processes. Then we have dependency management. So this ensures that your tasks are executed in the correct order based on the dependencies. And then you have policy enforcement. So you can apply your own organizational policies consistently across all automated tasks. The key features of cloud automation and orchestration, we have the first one, it is template-driven automation. So this is something like infrastructure as code. You use predefined templates of YAML or JSON to define your entire infrastructure. And this just ensures that you have a consistent deployment so that if anything breaks or if you lose your entire infrastructure, you can spin that up very quickly, very efficiently, and have it all back to working again. We then have auto-scaling. So auto-scaling just automatically scales your resources up or down. So either it adds instances or removes instances based on the demand. So if your application is getting a lot of usage and it's unable to handle it, like the CPU might be at like 90% or something, it's going to spin up more and more instances to account for that, all right? And then once the usage drops again, once it goes down, we're going to remove some instances so that we're back to baseline, right? And finally, you have lifecycle management. So you can manage the entire lifecycle of your cloud resources from creation to deletion. And let's have a look at this diagram right here. So this is just OpenStack orchestration with Heat. So Heat is what you will use to build out your infrastructure templates. So you have your Heat template here, your orchestration controller, and that will then build out your networks, your storage, your VMs, whatever it may be. Everything that is defined in your template will get created. And with that, you have your auto-scaling policy, which will, again, add or remove VMs. And yes, so that is how orchestration works in Rumble. Some of the benefits of why you would want this kind of automations is speed. So first off, it will accelerate your cloud resource deployment and scaling, and it will reduce any kind of human manual error because it does take a lot of time to recreate an entire infrastructure. You want this templated out so that it's nice and easy so that you can always refer back to it. Second point we have is consistency, okay? Having these templates maintains consistency. So it ensures uniformity across your deployments by using these templates and these automation tools. Finally, we have cost efficiency. So you can optimize resources through auto-scaling and preventing over-provisioning. So using too much when you don't need that much, right? So if you have an application that is running at 20%, you're not going to create another VM to balance that out because it's already at 20%. It still has some give. It can still take on more usage. There's no need to create any more VMs. Fourthly, you have scalability. So orchestration enables your systems to scale automatically in response to the varying demands or varying usage within your application. All right. So this is one of the biggest benefits of automation and orchestration. And finally, you have faster deployment. So having these templates, having these automations, these orchestrations, it will streamline your deployment process, allowing for quicker release cycles, okay? So you can test, you can build, and then you can deploy a lot faster than if you were to do all of these things manually. So in Rumble Cloud, Rumble integrates automation and orchestration as its core features to enhance your cloud management experience. They are very big on this. So they use tools like OpenStack Heat for your templates, and they do support that template-driven deployment and auto-scaling. So you have automated resource provisioning. You can quickly allocate and configure resources based on those templates and policies that you have set up yourself. You have auto-scaling. Adjust the number of running instances to match the application demand. This just ensures that your application is running optimally and not wasting resources or using too much resources. Then you have workflow orchestration. so you can coordinate multiple automated tasks to manage any complex deployments and operations seamlessly. So by leveraging Rumble Cloud's automation and orchestration tools, your business can optimize their cloud operations, improve reliability, and accelerate their time to market by really getting rid of these manual kind of bullshit tasks that really no one wants to do, because it can get messy if these things are not standardized and templated. So I'll just leave you with the summary and glossary here. You can review for yourself. Just a quick overview again, cloud automation just streamlines your tasks like resource provisioning, scaling, and monitoring, and it just enhances that efficiency and reduces any potential for human error. And then finally, you have your orchestration, which just coordinates multiple automated tasks to work together, and it ensures that your workflows are just executed in the correct order according to the policies that you have set up. So I'll leave you with this. Have a little review before we get into the next lesson. Thanks for watching, and I'll see you in the next section. In this lesson, I'll just go over the command line tools that Rumble uses. Quickly, Rumble uses OpenStack in its backend, so a lot of the commands that you will be running to manage your instances will be the OpenStack API as the backend. So what are command line tools? Command line tools are text-based interfaces that allow your users to interact with cloud resources by simply typing in commands. So they offer a powerful and efficient way to manage cloud infrastructure without relying on GUIs, so graphical user interfaces. These things offer you functionality, flexibility, and efficiency. So the benefit is you can create automations, so you can integrate your CLI tools into your scripts for automating these tasks. And it saves you a lot of time and does reduce a lot of human error. Command line tools also give you granular control. So you gain more control over your cloud resources by allowing precise configurations and adjustments. So you have the ability to perform more advanced tasks more efficiently. You don't necessarily have to use the dashboard. That's why these APIs and CLI tools are available. And then finally, you have efficiency. So you can execute tasks faster than navigating through those graphical interfaces like the dashboard or the console for Rumble. And this just gives you the ability to manage quickly your resources. Some popular command line tools that Rumble uses is OpenStack client. So the backend is built on OpenStack and everything runs on OpenStack, which is just for VM and instance management. So the first one we have is OpenStack client. It is just a CLI for managing various OpenStack services. It provides a consistent interface for tasks like creating VMs, managing your network, and handling storage. All right. A part of these command line tools, there are different CLIs in there. So you have Nova, Neutron, and Cinder. So these ones do separate things. So Nova manages your compute resources, like your VMs. Neutron handles your networking resources, including your subnets, your routers, and your floating IPs. And then Cinder manages your block storage volumes for your VMs. So if we have a look here at this diagram, we can see how these things work together. So if you, let's say, run the command OpenStack server create, this will create a VM in your cloud. If you run OpenStack container create my bucket, this will create the storage. If you run OpenStack network create my VPC network, this will create a VPC network. And within that, again, for your VMs, you can have different flavors, different types of instances, some with more RAM, some with more CPU, with storage. And for your storage, you can have your volumes, you can make them whatever size you want. And for your network, you have a lot of granular control over what kind of network that you want to build out. So a couple examples of OpenStack commands. The first one being listing servers. So nice and easy. You can do OpenStack server list. This will just show you a list of all of your active virtual machines. If you want to create a new VM, it's this nice long, nice command, OpenStack server create. You put in your image name, the flavor that you want, so the type of CPU, RAM, and storage, your network, what network you're using, and your key name. So this is just a name. This will create a new virtual machine with your image, flavor, network, and your key pair. Then finally, another example is just deleting a VM. So it's very simple, OpenStack server delete, and then you just put in your server name. This will just delete the specified virtual machine. So just a couple simple commands. We're not going to dive too deep into this because this is part of another course. This is just a couple examples to show you what OpenStack is and how to use those commands. So CLI tools in Rumble. So Rumble Cloud provides a command line interface for managing your cloud resources. Again, the backend is OpenStack, so it'll be using the OpenStack APIs, right? And this will allow you to manage your resources, automate your tasks, configure your services, and integrate with other tools, all right? Nice and easy. I'll leave you here with the summary and glossary, but I will do just a quick kind of rundown of the benefits of using the CLI tools. One, it's speed. You get faster task execution compared to the GUIs where you have to kind of mess around in the dashboard. You can automate, so you can create scripts, repetitive scripts to enhance your productivity and speed. And then you have control. You just have more precise management of your resources by running these CLIs. So again, you can do all of this with Rumble. Remember, the backend is OpenStack, so it'll be OpenStack APIs. I'll leave you with the summary and glossary, and you can have a little review before the next lesson. Thanks for watching. I'll see you in the next section. In this final lesson for Module 4, we'll talk about management. So managing your VM instances. A lot of VMs run Linux operating systems, so you will have to be very well versed in Linux. So let's talk about these Linux commands now. Linux is widely used in cloud environments because it's a stable, secure, and a flexible OS. So understanding basic Linux commands is really essential for effectively managing your cloud infrastructure, performing administrative tasks, troubleshooting issues on all of your virtual machines. So it's very important that you understand Linux. This is my favorite part. It's the most fun part because you can actually go into a VM and just start playing around with it and seeing what commands do. A few basic Linux commands that you should know. The first one being ls. All right. So this is listing files. This will just display the contents of a folder or a directory in long format. Okay. So it'll list out all of the folders and files and everything that you have under that folder. Next one is changing directory. So cd. cd will move your path, so your current path, so you can change the current working directory. So if you are in folder, let's say testing, and you want to go back, you would do cd ... So all this does is it tells Linux, okay, I want to go back a directory. So we're going to go back a directory. If you want to go into some folders, so let's say you have testing, and underneath that you have 3 different folders, and underneath this one, let's say you have scripts. If I want to get to the script folder, all I have to do is cd scripts. And then that will change my working directory to the scripts directory. Then you have CP, you have copying files. So all this does is copies a file from one location to another. And if you don't specify your destination, it will just copy that file in your current working directory, all right? The final one that you should know is moving or renaming files. So the move, the MV command, acts also as a rename. You can move or rename files and directories with this command. So you just put in your old name and your new name, and it renames it. Or you can simply just put a path to another directory as your new name, and it will move that file or folder. Another set of Linux commands is for system monitoring. So we have the top command, and this is for checking running resources, all right? So this displays in real time the information about your system processes, okay? So this will display your CPU usage and your memory usage currently as it is. The next one you have is DF, or disk usage. So this will show you how much disk space is used and how much is available on all of your file systems or your mounted file systems. And lastly, we have file permissions and management, all right? So chmod is used to modify the read, write, and execute permissions of a file directory. If you, for example, run an ls command, in that ls command, it will show you the permissions of each file. Now, these numbers here, so 755, these are permissions. So different values have different types of permissions. So some values, let's say 755, this will have read, write, and execute, for example. Maybe you have something like 500, which just does read and write, or maybe you have something like 400, which just does read, okay? So this is how you are able to change file permissions in Linux. Then you have secure file transfer. We quickly brushed over this in a different lesson, but this just allows you to securely copy files between 2 machines. You have your remote host and the path where you want to put that file that is on your current machine. Rumble Cloud's virtual machines typically run in Linux, so it makes these commands invaluable for managing your applications and resources. So with Linux commands, you can manage applications, monitor resources, manage your files, and troubleshoot a lot of issues that can come up in your VM, all right? So that's why it's very important to understand Linux, to understand the commands and the things that you can do with these commands so that you can efficiently and properly manage your virtual machines. So just to summarize, Linux commands are essential tools. You have to know them if you want to properly work in the cloud and manage your virtual machines. Just remember these commands. These are just the beginning. There is a lot of other commands that you have to know for more advanced usage, but for now, these should do you well. I'll leave you with the summary and glossary, and you can have a little review before we get into the next module. Thanks for watching. I'll see you in the next section. Welcome back to Module 5. This is going to be a bit more advanced topics that we're going to be talking about. So the first lesson is Kubernetes, which is one of my favorites. I've included a lot of information in these slides so that you guys can follow along as I'm talking. So Kubernetes is an open source platform that automates the deployment, scaling, and management of containerized applications. So it simplifies the complexities of running applications across multiple containers and machines. This really allows developers to focus on building features rather than managing the entire infrastructure. So you can focus more on your application build and then later use Kubernetes to worry about the deployment and management of that infrastructure. So Kubernetes offers you automation. It streamlines your deployment and your scaling processes, so you don't have to worry about that. Then you have your management. So it handles the orchestration of containers across your different environments so that you can focus on development. It really frees up the developers from infrastructure concerns and enables much faster innovation. A few key features of Kubernetes is obviously container orchestration. So it automates your deployments and management of containers across multiple machines. It is self-healing, which means that it automatically will restart containers if they fail or reschedules them to another machine if that is necessary. And the biggest point of having an orchestration tool is auto-scaling. So this will adjust the number of running containers based on the demand of your application. So if there's an increase in traffic or an increase in resource usage, the Kubernetes autoscaler notices that and it launches different pods, or we can just call it VMs in this case, to manage that, all right? The Kubernetes architecture is not too complicated. It consists of nodes, pods, and clusters. Your nodes are just your machines, so your physical or virtual machines that run on containers, and these are called pods. Then you have pods, which is your smallest unit in Kubernetes. So a pod can contain one or more containers running together, all right? So you can have one pod with 3 VMs underneath it. Then you have your cluster, and your cluster is just a group of nodes that is managed by Kubernetes. This ensures that your containers are distributed and managed efficiently. So how does Kubernetes work? Kubernetes organizes your containers in a structure called a cluster, and this consists of multiple nodes. Each node is a physical or virtual machine that runs one or more containers in it. So Kubernetes serves as the control plane or command center for the cluster, and it makes intelligent decisions about where and how containers should run. So quick definition recap, cluster is just a set of nodes that work together to run the applications. Nodes is individual machines, physical or virtual, that host those containers, and the control plane just manages the cluster, schedules containers, and monitors their health. Remember that Kubernetes is self-monitoring, so it continuously checks the health of these containers, and it will restart failed ones and reallocate resources as needed to maintain optimal performance. So let's talk about the nodes quickly for a second. The master node will control the management of the cluster, and it will handle the scheduling and distributing of the workloads. The worker nodes, which are located above here, these execute tasks by running pods that host the containerized applications, all right? And then you have your Kubernetes API. So this provides a RESTful interface for you to manage clusters, deployments, and services, so you can even create scripts to manage your Kubernetes deployments. Kubernetes in Rumble. So Rumble supports Kubernetes for managing your containerized applications across your clusters. It offers a very easy to use Kubernetes dashboard so that you can easily deploy and scale through the Rumble Cloud interface. So as we can see here, we have the Kubernetes tab, and underneath that we have clusters and cluster templates. So your clusters, you can just create a one-off cluster for your use case. And for the create cluster, you can create a template so that you can rerun it as many times as you want. So very easy to do from Rumble Cloud. We won't go into deploying with Kubernetes in this course. That will be for another course, as it will probably take a few hours to explain everything. Just to recap, Kubernetes is your tool for managing your applications, your containerized applications, offering you automation, scalability, and resilience. So by organizing your container in clusters and handling tasks like self-healing, load balancing, and automated scaling. So Kubernetes allows your developers to focus on creating better applications instead of having to worry about the underlying infrastructure of the cloud. So again, with Kubernetes, we get automation, we get resilience, we get scalability, and we get efficiency. And with Kubernetes, Rumble Cloud users can efficiently deploy, scale, and manage their applications, leveraging really the full potential of containerization so that you can build the best applications and deploy very flexible, very easy cloud solutions. It's not as difficult as it sounds, but we will get into how to use Kubernetes in another course. This is just a simple overview to show you where it is on Rumble Cloud. Thanks for watching. I'll leave you with the summary and glossary, and I'll see you in the next section. In this lesson, we'll do a much deeper dive into OpenStack so you have a better understanding of what OpenStack is and how it is used in Rumble. just to remind yourself, this is the backend of Rumble Cloud, and you'll be using OpenStack APIs to manage everything on Rumble pretty much. So what is OpenStack? OpenStack is an open source cloud platform that provides infrastructure as a service. It enables your business to create and manage large networks of virtual machines, storage, and networking resources. So it is highly flexible and can be used to build public, private, or hybrid cloud environments. And this really caters to a lot of your business's needs. So remember, it is open source, it is versatile, and it allows for comprehensive management so you can handle your compute, your storage, and all of your networking. So this is a large overview of OpenStack. There's a lot of shit going on here. You don't have to know everything. I just left this here so you can have a look at everything OpenStack, how it kind of works, right? So all of these CLI clients and the cloud tools and GUI tools that are available. So the key components of OpenStack, how does it work? So OpenStack has a lot of different CLI tools that have different functions. So here we have, the first one is Nova, and Nova manages virtual machines and handles resource allocations. This is used for the compute service to manage your VMs, all right? Then you have Neutron, which is for networking. So this manages networking services such as your IP addresses, your subnets, your routers, and your firewalls. Then we move on to Cinder. So Cinder is for storage, for block storage. It provides block storage volumes that you can attach to your VMs, and it gives you a CLI for managing that. Then you have Glance, which is your image service, and this helps to manage your virtual machine images that are used for launching your VMs. If you look at this OpenStack architecture here, it's a much more dumbed down, much simpler version of the above diagram that I just showed. So you have your storage, which is under Cinder, your compute, which is under Nova, and your networking, which is under Neutron, all right? So these CLIs can be used together in parallel to create your cloud architecture. And all of these things can be automated using those key templates that we discussed earlier. So OpenStack works with APIs and services. So OpenStack components interact through these RESTful APIs, and it just enables seamless communication between them and allows you to integrate with a lot of different things. It does have a modular design. So OpenStack's modular design really allows the components like Nova, Neutron, and Cinder to function independently. So it makes it very easy to scale and integrate with cloud services. So here are, again, this is an old diagram, but these are just some of the command line tools that are used to create your cloud resources. So why do we use OpenStack? Why does Rumble Cloud use OpenStack? It uses it because it is open source. It's been iterated on so many times that it's really, really good, right? It's flexible, it's free to use, and can be customized to fit a lot of businesses' needs. It is a scalable software, so you can easily scale resources up or down depending on the demand, and it allows for interoperability. So it works with other popular cloud platforms and can be used to create private, public, or hybrid cloud environments. In Rumble Cloud obviously leverages OpenStack, as we've seen, to manage your compute, your networking, and your storage resources. However, the dashboard provides you an easy-to-use interface so you can do all of that, but sometimes you want more granular control, so it also provides you the API endpoints for the different services. So if you look on the right here, you can see some of the things that we talked about here. So you can see Cinder, you can see Heat, you can see Neutron, Nova, and there are some other ones here that we really don't need to get into right now, but these are the main ones that you will be using. And it gives you all the API endpoints so that you can manage your entire cloud infrastructure through OpenStack, right? Just a quick summary. OpenStack is a very powerful open source cloud platform that provides comprehensive infrastructure as a service, right? So it has a lot of different components like we've discussed, Nova, Neutron, Cinder, that handle these different services on the cloud. And the benefits of using OpenStack is that it is flexible, it is scalable, you can control your costs a lot better, so it reduces your expensive, and it has a lot of community support that integrates with various tools and services. So in Rumble, you can use OpenStack to manage basically everything, right? So I'll leave you with a summary. You can do a little quick review before the next section. Thanks for watching. I'll see you in the next lesson. In this last lesson, we've saved the easiest for last for some reason, but we got to go over it. We'll be talking about servers and how they are working in the cloud. In cloud computing, servers are virtualized systems that provide the resources to run applications and services. So unlike traditional on-premise servers that you see on the right here, cloud servers are hosted in data centers and can be scaled on demand. So this allows businesses to access computing power without the need to invest in physical servers. So you don't need to maintain, you don't need to buy physical servers, run cooling or any of that. All you need to do is just tell your cloud service provider how much RAM, how much CPU, how much storage you need, and you have access to that in seconds, right? So servers enable multiple virtual servers to run on a single physical machine, and it really does optimize your resource utilization. It also it also lets you easily increase and decrease server capacity based on your current needs. So it ensures that it is flexible and efficient. And finally, you have remote management with servers. So you can manage your servers from anywhere with internet access. So it makes administration and maintenance super, super easy. A few key features of servers. The main three are CPU, memory, and storage. All right. So CPU, this handles the computations and processing required to run your applications. So servers typically use multi-core processors for better performance. The more cores you have, the more tasks that you can run. So as you can see here, we have our physical server and a CPU underneath it. Then we have RAM. So RAM is used to store temporary data that applications need to access quickly. So RAM does not save the data. It just uses it at runtime as long as the application is running. And then later, if the application goes down, that random access memory is deleted. So more RAM allows the server to handle multiple simultaneous processes, and the RAM is located here. Storage. So storage stores your data permanently. It is not like RAM. So anything that you have in storage will be saved even if the application goes down. So typically nowadays we use SSD for faster access, for faster read and write speeds. However, we can use HDD for larger and less expensive storage. We can store a lot more with HDD, but SSD is the preferred nowadays for speed. So if you can see here on the right, we have our physical server, CPU, RAM, storage, and our manager. And then we have our hypervisor on the right here, which manages how much CPU, RAM, storage we give to our VMs. All right, so it splits that up nicely and optimizes your VMs for the best usage. The networking capabilities of servers. Now, this might go over some of your heads if you are a beginner, but no big deal. I just put this here so you know a little bit more of how networking works for servers. So servers have NICs, or network interface cards. So this enables your server to connect to a network and communicate with other devices. Think of it as something that just sits in front of the servers and it directs your traffic. Then you have bandwidth. Now, you may have heard this before if you've ever bought internet, but bandwidth is just the amount of data that can be transmitted over the network connection. If you have a higher bandwidth, this allows your server to handle more data and traffic. If you have a lower bandwidth, you're kind of screwed. You can't do too much and you'll be sitting around waiting for your data to transfer. The different types of servers in cloud computing, we have physical and virtual servers. The physical servers, in Rumble Cloud specifically, you have dedicated hardware that runs a single tenant's workload. So if I go to Rumble and I want to buy some servers, they will give me dedicated hardware that only contains my data, everything I put on there, and it's all mine. Now, some cloud service providers don't do this, which is pretty bad, right? Because it allows them to give off some resources to another customer. So my data can exist in the same hardware as somebody else's, which isn't exactly ideal. What you want, preferably, is dedicated hardware, because you may run into some compliance issues in the future if some customer wants their data to be separate from other users. So physical servers provide high performance, but less flexibility. However, your hardware or your data is secure in that server. Then you have virtual servers, which is your VMs, which we have been talking about through this whole course. Your virtual machines are running on a physical server that use virtualization technology, right? So your hypervisor is the mastermind behind creating your VMs using your physical server, and it spreads out those CPU, RAM, and storage efficiently, right? So this offers you flexibility, scalability, and isolation from multiple tenants, right? If we have dedicated hardware, which we do get in Rumble, which is a plus, that is ideal. So in Rumble Cloud, we have virtual servers created using Rumble Cloud's compute service. Now, in Rumble, you will always get dedicated hardware. So you will not be sharing with other tenants. Your data is secure. This handles compliance issues if your customers do not want their data sitting with other users. So this, in Rumble Cloud, it is scalable, flexible, and optimized for a variety of applications, from web hosting to data management. Just to summarize, the servers in the cloud are virtualized systems that will provide you with the necessary resources to run your applications and services efficiently. The key features of these servers are scalability, high availability, cost effectiveness, and flexibility, right? And the types of servers that we have are just virtual and physical servers. You'll mainly be provisioning virtual servers. You will not be really dealing with physical servers. That is all handled by Rumble and their own data servers, right? So Rumble Cloud really simplifies server management by providing you the tools for easy provisioning, auto-scaling, monitoring, and security. So leveraging these features, your business can ensure that your applications run smoothly, efficiently, and securely in the cloud with Rumble's dedicated servers. So I'll leave you with the summary and glossary. We have reached the end of this course. If you've made it this far, I'm proud of you. This was a very long one. I'll link everything in the description below, all of the slides that we have here. I'll leave you with this massive glossary, which just goes over all of the definitions that we have said throughout all the modules. It is pretty extensive, so take your time, read through it, make sure you understand everything. Again, this is just an intro to cloud computing. We will have another course coming out for Rumble, which will actually go through how to use the console, how to use the APIs, how to create VMs, create templates, run Kubernetes orchestrations, all that good stuff. Again, this is just an intro to cloud course, so you understand the concepts that we are talking about in future videos. Thanks for watching, and we'll hope to see you in the next video.